Modern industrial stamping is a violently repetitive environment. Inside these machines, steel dies are subjected to massive pressure, striking metal at blinding speed. If a single microscopic void or impurity exists inside that die, the repetitive stress will eventually tear it apart. When a tool fractures, the entire production line stops instantly. A shattered die sends heavy shrapnel through the press machinery. You are left with ruined raw materials, severely damaged equipment, and millions of dollars simply evaporating in lost production time. An automated manufacturing line is only as fast as the microscopic structural integrity of its core tooling. That level of integrity begins long before the steel is cut. It starts as raw, high-grade alloy blocks arriving right here at the Alma Steel and Alloys facility in Pune, India. The first step for every incoming block is logging it into a centralized, highly controlled system. Looking at the factory floor, you can see the scale of the operation. Almas maintains a massive inventory of specific grades like EN8, H13, and D2 to ensure readiness for diverse industrial requirements. The most critical phase of this intake process is ultrasonic testing. Specialized teams meticulously scan the internal structure of the raw metal. They are hunting for microscopic cracks and internal voids. These defects are completely invisible to the naked eye, but they are exactly what causes a tool to fail under pressure. Once a block is verified, an operator matches the material, like these heavy D2 flats, to the nearest standard size required for a customer-specific order. The verified stock is then sliced down by heavy-duty industrial bandsaws. This ensures the precise dimensions and block weight are calculated for final delivery. Finding a microscopic flaw during this intake stage is the ultimate insurance policy. It guarantees a defective block is caught long before it can explode inside a high-speed press. The verified block is dispatched to the toolmaker, where it faces its first physical stress test, high-speed CNC milling. Because Almas guarantees a consistent, defect-free grain structure, the milling bit can carve out the exact die shape flawlessly, without snagging on hard spots or tearing the metal. Next comes a brutal physical challenge. High-performance cold work tool steels, like these 1.2379 D2 bars, require extreme heat treatment to perform their job. The material is deliberately subjected to intense thermal shock, heated in a furnace to well beyond 1,000 degrees Celsius. Following this is the rapid quenching process. By aggressively cooling the metal in oil or air, the internal molecular structure is locked into a hardened state. A sudden, massive temperature shift like this is violent. If the steel is low-grade or carries internal stresses, it will warp out of shape, shrink unevenly, or crack wide open. To balance this out, a subsequent tempering phase carefully reheats the metal. This reduces the brittleness while locking in a uniform weapon-grade hardness across the entire block. Only chemically pure, structurally verified steel can survive this thermal gauntlet and emerge as a hardened industrial tool. The hardened block then moves to the grinding phase, where its top and bottom surfaces are aggressively flattened to exact dimensions. The intense friction of the grinder generates immense localized heat. The baseline structural stability of the steel is what prevents it from buckling or warping under this friction. This brings the metal to its final and most delicate test, electrical discharge machining or wire cutting. EDM passes electrical current through a moving wire, sparking across a microscopic gap to vaporize steel into exact shapes. If this wire hits a single hidden void, the arc is interrupted, instantly snapping the wire and ruining a multi-day cut. Flawlessly completing a cut of this complexity is only possible because the block passed its initial ultrasonic testing back at the warehouse. Achieving micromillimeter machine tolerances depends entirely on the perfect density of the raw material. We finally reach the assembly floor, where the individual, fully machined components are brought together. The completed cold work die slots together effortlessly. The fit is seamless and frictionless, snapping into place with the exactness of a luxury watch. The final finished tool is delivered directly to the customer and is securely locked into a massive industrial production press. The machine roars to life, churning out flawless consumer parts at maximum speed, safely and continuously. The most brilliant engineers and the most advanced CNC machines in the world cannot save a tool that was carved from flawed steel. Alma Steel and Alloy's dedication to rigorous testing and inspection serves as an invisible, reliable force that keeps modern global industries running without interruption. True industrial precision does not simply start on the factory floor. It starts the exact moment quality steel is chosen.